All right, so we're going to start by looking at the inverse sine function. So it's really kind of unclear how to solve algebraically because these are trig functions, not algebra functions. So we're going to go with the graphical method to start here. So let's take a look at the graph of y equals sine x. Here's another moment to pause your video and see, do you remember what the sine function looks like and can you graph it? All right, so for me, I'm going to draw two periods of this sine function from negative 2 pi up to positive 2 pi. And then we have 1 and negative 1 on the y-axis. All right, now what we talked about with graphing an inverse function, the way that we would graph an inverse function is by drawing the diagonal line, y equals x, and then reflecting our graph across that diagonal line of y equals x. Okay, so what is this going to look like? Well, let's see, this first branch here, when we make this hill is now going to look something like this, and upwards, and then down below we have this other portion of the graph. Now, here's a problem, because I've reflected this sine wave across y equals x, and it gave me this sine wave that wiggles back and forth across the y-axis. And this is a problem because what we're saying is that our inverse function is this graph, but that graph is not a function. It does not pass the vertical line test. So here's one more bit of information about inverse functions in general, is that not every single function has an inverse. Okay? In order for a function to have an inverse, a function must be 1 to 1. So a function must be 1 to 1 in order to have an inverse function. Now, that's a problem. So what does a 1 to 1 mean? Well, 1 to 1, graphically what that means is that means that a function passes the horizontal line test. Okay? So in order to have an inverse, anytime on the original function that you draw a line, that horizontal line cannot pass the graph more than one time. All right, now that's a problem here because in this example, I mean, I can draw any kind of a horizontal line right here. Here's a horizontal line, and that has crossed the sine function 4 times, and that's only through 2 periods. So the sine function does not pass the horizontal line test, which means it is not 1 to 1, which means that this sine function does not have an inverse. Wait a second. This whole section is on inverse functions, and this sine function doesn't pass the horizontal line test, which means it doesn't have an inverse. So how do we make sense of that? What do you think, Ariana? What do you think? She doesn't have any ideas either. Okay, well, here's how we deal with this. The thing is that to come up with an inverse function for the sine function, we are not going to use the entire sine function. We're going to restrict it to a certain portion of it. Okay, so here's how we're going to do this. We must restrict the domain of the sine function so that sine of x is a 1 to 1 function. All right, so here's our picture. I'm going to redraw the sine function. So we lost 2 of our assistants. We lost Franklin and we lost Ariana, but we do have Midnight here with us now, so hopefully we can continue. All right, so we have our sine function drawn here now, and again, this sine function does not pass the horizontal line test. I can draw a horizontal line and it crosses the function more than one time. So we need to restrict the domain. We're going to cut off this function. And the way that we're going to choose to cut off this function is we are going to look at x values that start at negative pi over 2 and end at positive pi over 2. So I want to be really clear about this. The only portion of the sine function that we care about when it comes to writing down the inverse function, the only portion that we care about is this portion that starts at x equals negative pi over 2 and ends at x equals positive pi over 2. So because that part is so important, I'm actually going to kind of erase, I'm going to do a poor job of erasing so you can kind of still see it, but I'm going to erase the rest of that sine function because we do not care about that when it comes to talking about the inverse function. So this portion, we're going to be talking about the domain of our sine function, and we'll call it our restricted domain for our sine function. The restricted domain is x values from negative pi over 2 up to positive pi over 2. Okay. Now, one thing to notice is that on this restricted sine graph, the y values still go from negative 1 up to positive 1. So the range is still negative 1 to positive 1. Okay, so we are going to take this picture of our sine function and we are going to reflect this portion of our sine function across the line y equals x. All right, so here is what our inverse sine function is going to look like. Y equals inverse sine of x. And the way I write that is with that superscript 1 up here. Okay, so here's our picture, or at least the x and y axes. When I look back over here and I kind of envision what this is going to look like, I see this part that's sort of curving down to the right is going to sort of curve up. And this portion down here is going to reflect across the y equals x line as well. And I would encourage you to pause the video and kind of envision what this picture will look like. Now, as some guidance for this, another observation that we made about inverse functions is that the x's and the y's flip-flop. So on our original function, on our sine function, there are kind of three important points on here. One of the points is this point on the lower left side, which is the point negative pi over 2 comma negative 1. That point, when we flip the x's and y's, will become a point on our inverse function. So flipping the x and the y, I have negative 1 comma negative pi over 2. So here's negative 1. And down here is negative pi over 2. So one of our points on our graph will be the point negative 1, negative pi over 2. Okay. Our next point is this point right here in the middle, which is 0, 0. So if I flip the x and the y on that point, I still get 0, 0. So on this picture, one of the points on my graph will be the point 0, 0. And the last important point on our sine function over here, the portion of the sine function that we're going to care about, is this point where the x value is pi over 2 and the y value is positive 1. So here is 1 on the x-axis, and here is pi over 2 on the y-axis. So we have this point 1 comma pi over 2. Okay, so I would encourage you to, again, think about the shape of what our reflection across the y equals x diagonal line will look like. We have 3 of the points plotted, and I'm going to draw the rest of this, and I want you to imagine what it would look like and see if you can draw it before you see me draw it up here on the board. Okay, so here is a picture of the inverse sine function. So this is your first meeting with this function. The first thing you do when you meet somebody on a date is that you learn their name. Here's its name, y equals inverse sine of x. Another name, a nickname for this function, is sometimes this function is called arcsine, A-R-C-S-I-N, so arcsine of x. Okay. Now, this function, it's a little bit strange. You might be thinking to yourself, oh yeah, these arches kind of continue off forever and ever. They don't. This is it. This graph only goes from x equals -1 to x equals +1, and only from y values from -π/2 up to +π/2. There's no more graph. I've drawn the entire function. Okay, so let's write down some properties of this function. I guess we'll do it in the middle here. So properties of y equals inverse sine of x or y equals arcsine of x. The most important properties for most functions are the domain and the range. So we'll start there. Now, when we talk about an inverse function, we are swapping the x's and y's from the original function. We are swapping the inputs and the outputs. So what was the output on the original function is going to become the input on our new function, on our inverse function. So our domain, our range from the original function is -1 to 1. So now our domain for our inverse function will be -1 to 1. That makes sense from our picture. We have x values from -1 to +1. Our range, well, range is an output. So what was the input on the original function becomes the output on our inverse function. So our range for our inverse function will be -π/2 up to +π/2. And that makes sense from our picture. Here's -π/2, here's +π/2. We have those y values showing up. Okay, so that is our domain and our range. Some other observations that are important. When we're thinking about an inverse function, it's really important to keep really clear about what the input value is and what the output value is. So to think carefully about those, I want to go back to the original function. On the original sine function, the input in a sine function, the thing that we input in here is an angle, sine of 30 degrees, sine of π/2. These are angles, and so in the original function, the input is an angle, and the output that we get for our sine function, when we input an angle, sine of 30 degrees, the output that we get is, in the case of 30 degrees, sine of 30 degrees is 1/2. Well, that 1/2 is a ratio of sides of a triangle. In the case of the sine function, it's opposite over hypotenuse. So the output of the sine function is a ratio of sides, and in particular, we're talking about the opposite side over the hypotenuse side. Okay, so how does that play for our inverse function? For our inverse function, we're swapping the inputs and outputs. So when we talk about an inverse function or arcsine function, when we're looking at arcsine of x or inverse sine of x, that x, that input into our function, that is going to be what was the output. So on our sine function, the output is a ratio of sides, meaning opposite over hypotenuse. Then our input for our inverse sine function, that means the thing we're plugging in for x into inverse sine of x or arcsine of x, that input, that number is a ratio of sides of a triangle. In particular, we're looking at an input that is representing the opposite side of a triangle over the hypotenuse side of a triangle. So we input that into the function, and the output we get for arcsine of x or for inverse sine of x, the output we get is an angle. Okay, now thinking about what's going on. So the output of our inverse function was the input of the original. So the input of the original was an angle. So the output of our inverse function is also going to be an angle. Now here's the part that can be a little bit tricky, okay? And I want you to focus on this part. Our output is an angle. Now, when I look at this picture over here, the y values that I'm allowed to have as an output are angles of negative pi over 2 up to positive pi over 2. So our output is an angle theta, where that angle theta is between negative pi over 2 and positive pi over 2, which means that we are only going to be allowed to have output angles from quadrant 4 and quadrant 1, from an angle of negative pi over 2 up to an angle of positive pi over 2. And what I'm saying here may not make a whole lot of sense right now, but in our class on Wednesday, we will be working with these functions and using them in expressions, and knowing this piece of information right here, that the output for the arcsine function has to be an angle between negative pi over 2 and positive pi over 2, that knowledge is crucial for coming up with correct values when we evaluate inverse sine functions. Okay, so now we have all of the information, all the properties about the inverse sine function. Things that you're going to want to know about are the domain, the range, what is the input, what does the output tell you, and a picture of the inverse sine function. Okay. And before we wrap this up, I also want to talk about graphing this particular function. Okay, so when I look at my graphing calculator, I can see on the graphing calculator these buttons. I have the sine, cosine, and tangent button, and right above that I have sine with a superscript 1, cosine with a superscript 1, and tangent with a superscript 1. Those are my inverse functions. And again, that does not mean 1 over sine, that means inverse function, which swaps the input and output. So let's graph this guy. So we have y equals, if I want to graph the arcsine or inverse sine function, I hit the second button and then sine. So now I have inverse sine of x. And to start with this, I'm going to start with a zoom standard. Zoom standard, hi Franklin. Zoom standard gives us x values from negative 10 to positive 10 and y values from negative 10 to positive 10. Hey buddy, come on. Okay, so let's hit enter. See that? That is our graph. That's it. Now this is sort of a waste of space out here, so I'm going to zoom in on this, but I want to emphasize that that is it. That is the entire arcsine function right there. Okay, so let's change our window now. So remember that our domain are x values from negative 1 to positive 1. So let's change that now. So we have negative 1 and an x maximum of positive 1. And our y values, that corresponds to our range, and our range goes from negative pi over 2 to pi over 2. So I'll type in negative pi, oops, I forgot the negative. Negative pi over 2 up to positive pi over 2. As soon as I hit enter, it changes my pi over 2 into a decimal value, and that's okay. And I don't really care what the y scale, well, actually I do care what the y scale is. I'll just make the y scale, let's do pi over 4, because then I'll get some marks in the middle. Okay, so I'm going to go ahead and hit graph. And there is a picture of our arcsine function. Down here in the lower left is negative 1 comma negative pi over 2. In the middle we have 0, 0. And over on the right hand side we have 1 comma positive pi over 2. All right, so get to know this function. We're going to talk about the inverse cosine function and the inverse tangent function in our next set. Thanks.